me get there. Lesson 1. So we're still dealing with functions. Now, functions usually means graphs, okay? But luckily for us, besides one tiny graph today, you don't actually have to graph any of them this unit. We're just taking the equation of the function, and we're dealing with the equations, not necessarily graphing them, okay? Today, we are going to be finding the sum and difference of functions. So very simply, I'm going to give you two functions or two equations, and we add the two equations together, or we subtract the two equations. So it's just adding or collecting similar terms. It's not so bad, okay? So this is how it's going to look. We know that a function might be represented by like f of x. So that could be our first function. And then we have another function, maybe represented by g of x. They're two different ones. That's why I chose two different variables. When we add them together, it will create a new function. So if we add two things together, we'll have a new result. We'll call that h of x. You can use any letters you want, okay? As long as it's different. This is just another way of writing the same thing. So f of x plus g of x, as it's written like this, can also be rewritten just as f plus g in brackets with an x. Okay, I just want to show you both of those. They mean the same thing. The exact same thing happens when we subtract. I take my first function, I subtract off my second function. The result will be a new function, h of x. And then again, another way of writing it, instead of f of x minus g of x, it's just f minus g in brackets of x. So that's kind of the notation we're going to be looking at, so you don't have any surprises coming at you. Let's start with examples right away. So here's my first function. I am telling you f of x equals 2x plus 1. That's my first function. If we were to graph that, which we're going to in this example, it would just be a straight line. Easy peasy. Then I have another one. My second function is g of x equals x squared. That would be a parabola starting at our origin, right? So I want you to determine the equation of the sum of the functions. So we are going to add these guys up. So in other words, I want to know what is f of x plus g of x. That's all I want to know, okay? This is where you choose a third random letter to create your new one, like your third one or your new one. So usually I use h of x. So if I take h of x, all I have to do to find h of x is take my first one, which is 2x plus 1, and add it to my second one. I took my first function, I added it to my second function. And all you got to do is just simplify now, or add if you can. You cannot add any of those terms together. One's an x squared, one's an x, one's a 1, right? So all I would expect you to do at this step here is just to rearrange these guys in decreasing order. So it looks like a nice trinomial. And there you go. You found the sum of the two functions. Can we handle that? Pretty simple. Okay. Now we're just going to sketch these. This is the only graph I'm going to expect you to draw this unit. Okay. So what I want you to do is sketch the graph of f of x, that's the straight line. Sketch the graph of g of x, that's the parabola. And then we're also going to sketch the graph of h of x, which is the new guy, all on the same Cartesian plane. Okay? So this is what I believe to be the easiest way to do it. You can organize your work however you want, but I like tables. I like things to be organized with columns and rows. So this is what I'm going to do. Whenever we graph a function, don't I usually say x is -2, -1, 0, 1, 2? We're going to use that same deal, okay? So I'm going to choose x values of -2 to 2. And you'll see I made my right-hand column really big because I'm going to split that up into 3 of them because I have 3 graphs to draw, do I not? So I'm going to make this one my f of x. I'm going to make this one my g of x. And I'm going to make this one my new function, h of x. Okay, so all you have to do is fill these in. So you first of all have to take your f of x function, which was the 2x plus 1, and plug in -2. So I'm going to show you that step here once, and then I'm going to fill it in for you. So 2x plus 1, so that would be 2 times negative 2 plus 1, right? Or you guys could just write negative 3. So I just want to show you that's how I get the negative 3. I'm going to erase this now and just fill in for you, okay? So this guy is negative 3. If I go down the line, then I get negative 1, 1, 3, 5. So I just plugged all of these into 2x plus 1. That's how I got those. Okay, now I'm going to do the same thing for g of x. So g of x is just x squared. So for the first guy, that would just be negative 2 squared. That's how I'm going to get 4. Then I'll just fill in for you. If you just square all these values, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So I just got those by plugging in to x squared. Now, make your life easy. H of x has a big old nasty equation, right? X squared plus 2x plus 1. If we're going to sub these values into that big trinomial, that would work. It would just take you some time. The other option is just to add these values together, because that's what h of x is ultimately, right? Is f of x plus g of x. Yes? So you can just add your values together. So it's actually quite simple here. Negative 3 plus 4, 1. Negative 1 plus 1, 0. 1 plus 0, 1. 3 plus 1, 4. 5 plus 4, 9. Isn't that easier? By all means, you can plug it into that trinomial. Okay? Or just add them up. I think adding is easier, of course. Okay, so now what we're going to do is we're going to graph all three of these, and they're going to overlap, but that's okay. So I'm going to start with f of x, and I'm going to graph f of x in green, just so you can kind of tell which one is which. So for f of x, my first point is negative 2, negative 3. Then I have negative 1, negative 1. And then 0, 1. And remember, this is the straight line, yes? So we can see the slope happening, right? The slope is up 2 over 1, up 2 over 1. So you can just kind of go by that pattern after all. 1, 3, 2, 5. You take your ruler. There you go. I'm going to label this guy. That's my first guy, f of x, which was 2x plus 1. Okay. I hear you guys getting all your stuff. I'll just give you a second. Okay. Next, I'm going to do g of x. I'll do g of x in red. Little light flicker there. Okay, so my points for my parabola, when x is negative 2, y is 4. When it's negative 1, it's 1. I have a 0, 0. I have a 1, 1. And then I have a 2, 4. So I'm just looking at the x values and then the column, the second column in the g of x column. So like we said, x squared is just a parabola going through the origin. G of x equals x squared. There's that guy. So that's the two of them separately. Now we're going to draw the function that's the sum of the two, and I'll do this guy in blue. And I just look at my points. Negative 2, 1 is right there. Negative 1, 0 is on the x-axis. Then I have 0, 1. Right? Sorry, 0, 1. Yeah, right here. And then I have 1, 4. And then I have 2, 9. So you can see with the points that we chose, the negative 2 to 0, this is a parabola, the blue guy, but it just so happens that the points we chose gave us more points on the right side. You know what I mean? Okay. So remember, parabolas are always symmetrical on the left and the right. So if you want, you could just assume that we're going to go through like this. Okay. It's just a rough sketch. So really, when we add these guys together, all that really happens is everything gets shifted. Like the blue guy just got shifted a little bit to the left. Okay? So that's what happens when you add those guys together. That's the only graph we're going to graph today. Now, the last thing I asked you here was state the domain and range of h of x. So that's the new guy. So that's my blue guy. We're very good at domain and range by now. So your domain, it's just a parabola. So your values go left and right forever and ever. Okay, but your range for that parabola is different. It only goes up starting at 0, where y is 0, right? So you would say y is greater than or equal to 0. And of all those other values, it only hits real numbers. Easy enough? Okay. Next question, still related to this one we're doing. Now I want you to determine the values of h of x when x is 4. So my table of values only went up to 2. I'm asking you to figure out what is h of x when x is 4. There are 2 ways to do this. I will show you both ways. We kind of talked about them already. So method number 1. The first way to figure out what h of x is when x is 4 is to first figure out what f of x is when it's 4. And then what's g of x when it's 4. Okay? So you don't have to write that down. I'm just trying to show you what I'm going to do. So I'm going to say when f of x is 2x plus 1, right? And I plug in 4, I get 9. Then when I do the same thing with g of x, which is x squared, and I plug in 4, that's 16. So then all you have to do to find h of x is to add those two together. So you get 25. That's method number 1. You just find the 2 first guys to give you the third guy. Method number 2 is to take the new equation of g of x, because not g of x, sorry, h of x. We found h of x in the previous question to be x squared plus 2x plus 1. And then you can just plug 4 into this guy and do it this way. So I get 16 plus 8 plus 1, which is also 25. So I don't care which way you do it. Plug it into the actual new equation or plug it into the 2 old guys and add them up. It's all the same in the end. Okay, easy enough. Number 2. Let's start a new question now. If f of x is x plus 1 and g of x is 2x minus 5, we're going to determine all this stuff I'm asking you for here. So the first thing I want you to figure out is what's your h of x? That's our new third function. And this is that other way of showing that we're adding them together. Remember, in other words, that just means this. So once again, I am just adding up my 2 functions, okay? So h of x would be x plus 1, that's my first guy, added to 2x minus 5, my second guy. Collect like terms, which we can actually do here. X plus 2x is 3x, and 1 minus 5 is negative 4. So there's my new h of x. All right. B, I want you to find the domains of each guy without graphing them. So this is where you kind of have to almost graph them in your head and kind of figure out what are my x values doing. So for f of x, look at just f of x, which is just x plus 1. What type of graph is that? It's a straight line. What's the domain of straight lines? X is an element of all real numbers. It goes left and right forever. Look at g of x. It's a straight line again, right? 2x minus 5, same thing. So that's going to be linear. Look at h of x. H of x is 3x minus 4. Yet again, that is still a straight line. So all 3 of these have the same domain because they are all linear. Easy peasy. Okay, so for the first time for C, we're going to do a subtraction. All right. So that's why I gave you a new letter, because h of x has already been taken for the addition. Now I'm doing a subtraction, so I'm going to get a fourth function. So I chose P. Okay, so in other words, P of X is equal to F of X minus G of X. Okay, order matters. I put F first, so you put F first. All right, so P of X would equal, I take my F of X, which was X plus 1. Any guesses on what I got to be careful with here when I minus it off? I'm going to put brackets around my G of X because we know that subtracting throws a wrench in everything, right? It has to apply to both terms in there. So this is actually X plus 1 minus 2X plus 5. So P of X, if I clean that all up, that's negative X plus 6. So there's my P of X. Okay. Now, D wants me to find all 4 of my functions, F, G, H, P, at negative 3. So first I'm going to find F at negative 3. So F at negative 3 would be negative 3 plus 1, because my F function was just X plus 1. So my F function is now negative 2. Then I'm going to find my G function at negative 3. G was 2X minus 5. So I have 2 times negative 3 minus 5, that's negative 11. Now, don't reinvent the wheel here. You don't have to use your H equation because we know H was the result of adding the 2 together. Yes? So I just go negative 2 plus negative 11. I just added my 2 answers together, and that gives me negative 13. By all means, if you want to double check by plugging in the negative 3 to the H function, absolutely. And finally, P of negative 3, don't reinvent the wheel. I know that that is a result of a subtraction. So negative 2 minus negative 11, I'm going to minus the 2, and that becomes negative 2 plus 11, which is 9. Easy, right? Is today awesome? Those psych kids are missing an easy one. Okay. All right. New question. If f of x equals 5x squared, so that's a parabola, yes, with a stretch of 5, starting at 0. And then g of x is the radical of x squared minus 4. I want you to find the following. Then I want you to state the domain of the new function, okay? So first of all, I want you to add together f plus g, and I will say that that's h of x. Okay, so f is 5x squared, and I'm going to add that to g, which is x squared minus 4. You actually can't add those together. You know what I mean? They're totally different. One's an x squared, one's a radical. Even if you tried to square that guy to get rid of the radical, you'd have to square everything else too. And then you have 5x to the 4 and hx. No, thank you. Absolutely not. You're done. Okay, so if you can add them together, you can't add them together. You just leave it like that. Peace? Okay. X minus 2. No, you cannot. That's not how square roots work. Because x squared minus 4 is x minus 2, x plus 2. Really, so if you square root that, it doesn't just become x minus 2. Okay, so you just leave radicals as is, okay? Now, the next thing I asked was the domain. This is where it gets a little bit tricky in your heads because you have to visualize what both graphs look like and combine the 2 domains to get just one domain, okay? Now, what that means is I'll draw it out. You guys know how I like drawings. I'm first of all going to do a very rough sketch. You don't have to do these sketches. I'm just doing it for now so you can see what I'm talking about. I know that 5x squared is a parabola starting at 0. You need to just know that. Okay? So that's that. What's the domain of that guy? X is an element of reals. So I know the domain of my first guy is all real numbers. Yes? Now, you guys may not remember how to graph radical functions. Do you remember? I'm just going to go close the door. to graph a radical function, take a look at what's underneath the radical. X squared minus 4, right? If you ignore the radical, x squared minus 4 is a parabola that got shifted down 4, yes? So if I draw a parabola that was shifted down 4, like that, but then I take the radical of it, you cannot take the square root of a negative. Remember? So that's why, that's why you ignore this chunk down there. Yes? Because those are all negative values. So you kind of just ignore that chunk. So this is actually the graph, just those two wings, okay? So if I ask you to state the domain of this guy, well, this represents x is less than or equal to -2, and this represents x is greater than or equal to 2. How did I get the -2 and 2? I factored, right? X minus 2, x plus 2. That's how you find your x-intercepts, right? X minus 2, x plus 2, that's how I got those. So on the left, it's less than -2. On the right, it's greater than 2. So this is where we kind of have a domain battle. We have a battle of the domains. Who wins? Okay, the guy on the left can be anything it wants. It has no restrictions, right? But the guy on the right, he has restrictions, so he wins. So you would just say that your domain for these two combined is the one with the restrictions. So x is less than -2 and x is greater than 2. And for all the other values, it hits that. Okay? Also in the textbook, instead of a comma in between those guys, you might see this. That means like a combination of, like they both exist on the left and the right. There's two separate ones. Okay? Let's do another one of those. That might be hard to wrap your head around. But this one, we're just minusing. We're minusing, but you'll notice I also flipped the order. I want G to come first, so be careful with that, okay? So I can't use h of x again. I got to choose a new letter because it's a new third function, or it's a fourth function technically. So p of x would be my g of x, which was my radical guy. And now I'm subtracting my f of x minus 5x squared. Okay, so now, again, you don't have to do this. But this first guy, I already drew it in the previous question. The radical of x squared minus 4 is just those top guys, so that domain doesn't change. That graph looks identical. The second guy is a parabola still, but what's unique about this parabola, or what's different about this guy in this question for the previous question? It's negative now, right? The 5x squared was positive in the first guy. Now he's negative. So it would be a parabola pointing down now. But regardless of that, the domain is still the same. The domain is still x is an element of reals, even though it's pointing down. That doesn't change. So technically, we still have the exact same domain. One is an x an element of reals, and one is less than -2, greater than 2. So the one with the restriction wins. So I'm just going to draw an arrow. The domain is the same. Okay, so sometimes your domain will be the same regardless of if you add them or subtract them. The one with the restrictions wins. Okay, last page of examples, almost there. Okay, something a little bit different now. I'm going to give you 3 functions. So I have f of x equals 2x plus 3, g of x equals -x squared plus 5, and h of x equals -x. I want you to find k of x, which k of x is just all 3 added together. So we're doing basic, like grade 9 math here. 2x plus 3 plus -x squared plus 5. You can put that in brackets if you want. You'll just have to clean up your symbols, but the brackets are not necessary because we're not subtracting. And then minus x. So if I clean this up, I get a -x squared out front. I'm going to reorganize at the same time. 2x minus x is a positive x in the middle, and 3 plus 5 is 8. So there's my k of x. Okay, this is where your preference comes in. I want you to find k of 2. So option number 1 is just to plug 2, oh, you don't have to plug it in there. Plug 2 in to where you see an X and be done. I think that's easier than plugging 2 into each separate and then adding all 3 together. I think just plugging it in here would be easier. You just have to be confident that you did this correctly, right? Okay. K of 2 will therefore be equal to negative 2 squared plus 2 plus 8, which is negative 4 plus 2 plus 8, which is 6. By all means, you could have plugged it into all 3 individually, then add. Okay, last question of the day. It's a little bit of a word problem with profit and revenue and all that fun stuff. So we have a cell phone company. It costs a cell phone company $25 to make a phone. So when they make a phone, it costs them $25 in like little materials and SIM cards and all that crap, okay? But they also have $45,000 in fees for equipment, for their power bill, all their fixed expenses, their rent, all that stuff. So it costs a lot of money to keep this company going. When they make a phone, they sell the phone for $100. Cheap phone. It's probably a crappy phone. That's okay. I want you to represent or develop a function that represents the cost it takes them to produce a phone. How much does it cost them to produce? How much money are they sending out to produce a phone? They tell you what letter they want you to use, C. Now, it costs them $25 per phone, right? We don't know how many phones they make, so we'll just say N. Because if they make 2 phones, it would actually cost them $50, 3 phones, $75, and so on. So we know it costs them $25 per phone, but then it also costs them an additional $45,000 in overhead to make a phone. So that's their cost formula or cost function. Then I want you to determine the function that represents the revenue when selling N phones. Revenue is how much money they make, not the profit. Profit is how much money they get to keep after paying stuff out. Revenue is just how much money they bring in total. So the revenue equals how much money are they bringing in? What piece of information did I tell you about how much money they get? $100. So that's the only revenue coming in is $100 per phone. Maybe they sell headphones and AirPods and cases, but it doesn't say that. Purely based on the phones, $100 per phone. That's the revenue. Now, finally, I want you to represent profit. Profit is their revenue, how much money they get to bring in, minus their expenses. So minus their costs. That's how you always find profit, FYI. If you guys start to run a business one day, that's a very easy formula. Your profit is how much money you bring in after you pay out stuff. So now if I want to actually figure that out, my profit is equal to my revenue. My revenue was 100 N, and my cost, I'm subtracting my cost. Be careful and put that in brackets because your cost has 2 terms in it. So you need to put brackets around it when you're minusing those off. So your profit would be 75 N, I'm just subtracting that, minus $45,000. That's how they figure out their profit at the end of a month or year or whatever. And the final question. How many cell phones must they sell to break even? In other words, their profit is 0. They haven't lost money, but they haven't gained money. So their profit is 0. They've broken even. So all you do is set profit equal to 0 in the profit equation, which was 75N minus 45,000. I'm going to send the 45,000 over to make it positive. I'm going to divide each side by 75. So they would have to sell 600 phones just to break even and have a profit of $0, which you don't want. You want a profit of more. They'd have to sell over 600 to actually start making money. And that's that. Okay? So your assignment is written down there. This would be due Friday. Today's Wednesday. You can get going on that. Stop the recording.